Thank you, everyone, for joining. My name is Adrienne Esposito. I'm the Executive Director of Citizens Campaign for the Environment. I'm joined today with my co-host.
I'm Julie Ty. I'm president of the New York League of Conservation Voters and the New York League of Conservation Voters Education Fund.
And we do appreciate your time today. The issue of battery storage has been a very hot issue, no pun intended, throughout the state of New York. A lot of municipalities are unsure what the technology is. A lot of members of the public have heard concerns and they call our offices and they have questions. And what we want to do is provide you with experts who can answer those questions. And that's what this forum is about today. We're going to be hearing from experts at NYSERDA, an expert from one of the companies, and an expert with the Energy Safety and Response group. So we hope we've brought together the team that can get your questions and concerns answered so you can have a greater understanding of battery storage and its role to play in the transition to renewable energy. So we're going to start today. PowerPoint, please. There we go. We're going to call this the battery energy storage systems, the basics. Okay, you know why. If you don't know why, I will tell you why, because of climate change. And we need to transition the way we produce, but also store energy in our nation. Climate change is real. It's not a concept. It's not a debate, but rather it's a scientific fact. We also know it's a fact. Even last year, again, the United Nations came out with another report verifying that climate change is caused by human activity. Next. The impacts are real. We see them, we feel them, particularly if you're living in New York City or you're living on Long Island, if you're living around the Great Lakes, you see them, you feel them, you know them. According to NOAA, between January and August, this was of last year, the country experienced 23 separate disasters. 253 people died, and each reported damage exceeded $1 billion for a total of $57 billion. So not only is climate change real, but it's expensive to all of us because we all foot that bill. Next. You remember it. It's hard to forget if you saw it. The apocalyptic skies above New York City, above Albany, which is where I was when I saw it, on Long Island. You know, Canada normally doesn't have wildfires. They have ice, they have snow, and they have a lot of lakes and a lot of water. And they normally don't have fires. But this last year, 27 million acres burned, a record amount for Canada. And that doesn't just impact Canada. As you can see, it impacted us. People actually had to stay indoors for over 7 days because of the particulate matter in the air. And that particulate matter is the material that causes respiratory ailments and even premature heart attacks. Continue. Last month, to give you some updated sadness, I'm always the bearer of bad news, but listen, that's the world we're living in right now. Last month, extreme storms hit the West Coast, causing deaths and $11 billion of damages. And as you may know, California was in an 8-year drought, but now they're being pummeled by torrential floods. There was an atmospheric river in Los Angeles dropping 11 inches of rain in 2 days and beating a 147-year-old record of rainfall. Next. Also, let's not leave out where we live. I don't know if you've been seeing the news lately, but just this week, the DEC released a new report on climate change saying that New York City and Long Island can see a 9 inches of sea level rise or possibly over a foot by the 2030s. 2030s is not that far away. It's 2024. So again, these aren't occurrences of the future. They're happening right now. So we must transition. Next.
So the state of New York, as we've talked about many times before, had passed a law in 2019, the Climate Leadership and Community Protection Act, which is the most ambitious climate law in the country. It requires us to transition to 70% renewable energy by 2030, which, as Adrian just noted, is not so far away, and to get to 100% carbon-free electricity by 2040. In addition to that, there's a goal of reducing all emissions across the entire economy 85%, including a reduction of trying to get to net zero by 2050, which could include some offsets. But that means we're going to need to transition a lot of things to electricity and other carbon-free ways of powering our economy. That includes a goal of 9,000 megawatts of offshore wind by 2035, although we are advocating for that number to go higher, and 6,000 megawatts of solar by 2025. Although I think now the governor has made that goal 10,000 because we're well on our way by 2030, including 40% investments in frontline communities to make sure that we're getting investments and reducing fossil fuel usage from people who have been on the front lines of climate change, in particular in those low-income communities and communities of color that have really been the subject of environmental racism and overburdened with pollution, as well as making sure that we're protecting the workforce, because we want to make sure that people have the opportunity to transition to good jobs as we transition off of fossil fuels and to a clean energy economy. So the next slide. We as part of that, the law also seeks to get 6,000 gigawatts of battery storage by 2030. Because we have these new clean sources of energy, we need to make sure that they're dispatchable and available at all times. And battery energy storage is a key to that. So we can take advantage of the fact that offshore wind is going to be producing power all night long when we're not using as much energy. We need to store that energy so that we can deploy it when we need it the most, more during the day and other times when we're not as optional. Similarly with solar, where in the middle of the day, we may not be using as much energy. And this is a way that we can help us get off of diesel power generators, for example, and onto much cleaner energy sources. So these are really critical on New York City, Long Island, in particular, to help with peak power demand. So we've brought in some experts to talk about this. First, we're going to hear from Phil Denara, who is Director of Development for Key Capture Energy. And then we'll hear from David Sandbank from NYSERDA, and then we'll hear from Nick Petrakis from the Energy Safety Response Group. But first, we're starting up with Phil.
Awesome. Thank you. Thank you to Julie and Adrian and your teams for organizing this event. It's a pleasure to speak alongside, albeit virtually, with David and Nick, who are certainly the subject matter experts within their respective fields. And thank you to all who are attending the webinar for engaging and being interested in learning more about energy storage and particularly battery storage. Key Capture Energy and the industry at large remains committed and into providing transparency and engaging with local communities as we work to develop these projects. I'm going to primarily focus on the what and why and the necessity of these projects, and then really hand it off to David and Nick to dive into the technical details of the design considerations and compliance with codes and standards that have posed many questions along the way. So a brief introduction to myself. I'm a Director of Development with Key Capture Energy. So my goal is to oversee the strategy and understand why certain locations make sense for battery storage on the grid. And then ultimately work through the process of studying them from an electrical perspective, permitting them within the local authorities having jurisdiction, and seeking out commercial offtake for the power and financing opportunities. Key Capture Energy was founded in 2016 and is engaged in the entire life cycle of the project. So everything from early stage development, procurement of the equipment, construction, contracting, and then ultimately operating the projects. We have headquarters in Albany, but are active throughout the United States and sit at about 100 people right now, including about 35 full-time hires in the last year. We do hire and have many interns from the state university program and maintain committed to investing in our local workforce and economy. Currently, we have over 600 megawatts of projects online throughout the state, and 3 projects totaling about 44 megawatts are online and operational in New York alone. So where does energy storage fit within the larger, fast, and complex clean energy transition that we're looking at? We're essentially in the process of moving from this conventional scenario, which is shown on the top right image, to this emerging scenario down below. So in the conventional scenario, we essentially have a one-way unidirectional flow of power. We've had incumbent fossil generation, typically in the form of either coal, natural gas, or oil, produced at large power plants, generating power and transmitting that over high voltage transmission lines. That power is then stepped down at substations to a lower voltage and then distributed through the local distribution network to retail residential customers, commercial loads, and industrial loads. Where we're heading is towards this emerging scenario, which is being driven primarily by the lowering cost of levelized cost of energy for large scale renewable development. So for the first time, we're at this inflection point where essentially the cost of generating power through the form of large scale wind and solar is cheaper than that of the incumbent fossil generation. And what that means is we're relying more on weather dependent intermittent renewable energy to produce our power. The wind is not always going to blow and the sun is not always going to shine. So inherently, there's a need for large scale battery storage to be able to essentially charge that excess cheap generation when it's being produced on the grid. For example, when the wind is howling overnight, but folks are mainly sleeping, and then discharge that back to the grid during peak periods of demand, which is the most economical choice from a cost perspective for ratepayers, and also supporting the integration of renewable energy. Additionally, we're seeing a lot of innovation in both the market dynamics and technologies themselves from what are called distribution energy resources. So residential rooftop solar on the tops of houses, batteries mounted through Tesla power walls or other technologies on the side of houses, EV vehicles, smart thermostats, all things that are capable of responding in real time and reducing their load when necessary to reduce congestion on the grid, and also at times discharge power back, which is creating this bi-directional flow of power. So who are the three major players for the large-scale interconnection projects that we're talking about primarily today? There's three major entities. The first is the independent system operator, which in New York is the NYSO. And the NYSO is a nonprofit entity that reports to state jurisdiction and is responsible for administering the wholesale market, so ensuring that the least cost, marginal cost of energy is that which clears in the market is ultimately delivered to customers, and also provides a comprehensive reliability planning and analysis to ensure that we're connecting these large-scale resources feasibly and safely into substations and transmission lines. Secondly, there's the transmission owners, your local utility, which actually owns that transmission infrastructure. And they're responsible for maintaining the uptime of those transmission lines and procuring the necessary generation capacity to be delivered to their customers. And then finally, you have independent power producers. So those incumbent fossil generation sources, the large-scale wind and solar, or battery storage, which is charging and discharging onto the grid like ourselves, which are actually bidding into NYSO's wholesale energy market. I know we have representatives and interest from across the state, and there's probably even attendees on these calls from outside of New York. But I want to give a specific case study of the benefit that energy storage can provide. And a great example of this is the Long Island fossil peaker replacement study, which was completed by a third-party technical consultant, Strategen, in 2021 on behalf of the industry. So looking at Long Island's grid mix today, you have a peak electricity demand of approximately 5,000 megawatts. Approximately 4,400 megawatts of that is fossil fuel generation, which is a confluence of large-scale power plants, which are providing baseload power, but also take a very long time to ramp up and warm up, and then what are called these peaker units, which are fast dispatching fossil fuel generation plants, which can essentially start up in real time, burn fuels in order to respond to real-time fluctuations in the grid. Where we're heading is essentially a lot of these assets are built in the 1940s and in the late 1900s, et cetera. And a lot of those assets are beginning to age and beginning to retire, and also the power purchase agreements that are essentially contracted to supply this power are beginning to expire. So we need to figure out how to transition off of these assets in a reliable and quick manner. The strategy and study essentially determined that it's feasible and cost effective to replace almost half of Long Island's existing generation capacity, those peaker plants, with energy storage by 2030, which equates to potential savings of upwards of $400 million for its ratepayers and also societal benefits. So displacing carbon emissions, which are affecting climate change, which Julie and Adrienne indicated, as well as sulfur dioxide and nitrous oxide, local harmful pollutants that are affecting the health of our communities at a very localized level. Next, I want to jump into a couple of our operating projects. So the first is our New York 1 facility, which is a 20 megawatt project in Saratoga County. This is a project that we built and brought online in 2019. It's been operating efficiently and safely since it was brought online. As you can kind of tell in the backdrop of this image here, there's a really large industrial facility that's actually a global foundries silicon chip manufacturing plant. And because of that load and other loads nearby, there's a need for what's called ancillary services to maintain and provide reliability for the transmission system. So this project is actually responding to signals as fast as within milliseconds to charge and discharge and maintain frequency on the grid. Our next project is our New York 3 facility, which we built in 2020. This was a project in Pomona County down in the Hudson Valley, which we built on behalf of Orange and Rockland Utilities, which is a subsidiary of Con Edison. Essentially, Orange and Rockland had identified thermal overloads on their transmission system because of growing electricity demand, and had determined that it was cost effective for its ratepayers to site an energy storage project near the substation and load, rather than building new costly and expensive transmission infrastructure that would have been paid for its ratepayers. So essentially, the project is capable of charging during lulls and overnight periods, and then discharging that back during peak periods of demand, which is displacing the need to have transmission build out and energy being transmitted from other locations of the state. And then finally, this is our third and largest operational project, which we brought online last year. This is a 20 megawatt facility, so the same size as New York 1, but it's a longer duration battery. So it's capable of charging, instead of just providing frequency regulation over the short term, it's capable of providing power over a longer period of time. Finally, I just wanted to highlight one of our larger projects, which is actually down in Texas. This is a 100 megawatt facility. So across the globe, but especially in markets like California and Texas and Arizona, we're seeing substantially larger projects than are deployed here in New York today, to the tune of thousands and thousands of megawatts. These are projects that have been operating safely and efficiently, and technology has progressed quite a long way since this market really kicked off about a decade ago. Just finishing with one last discussion point before I hand it off to David, which is just to talk about siting and permitting. So currently, energy storage is subject to the local entitlement process. So unlike environmental review and permitting of major renewable facilities like solar and wind, which are administered by a state entity in the form of the Office of Renewable Energy Siting called ORES, battery storage is still subject to local town approvals. So when the CLCPA, which Julia and Adrienne mentioned earlier, was enacted and set the clear climate mandates, NYSERDA began to understand the writing on the wall and created what's called the NYSERDA Model Law. And the Model Law is essentially a draft law which is intended to help local governments and officials and AHJs adopt legislation and regulation to responsibly accommodate these projects. So towns can review the NYSERDA Model Law, understand how to incorporate into their own town code based on their own zoning districts or where they see these projects being feasible, and then enact that so it allows for a clear permitting path moving forward. These large-scale battery energy storage projects can take 3 to 5 years to develop. We're doing these complex interconnection studies, we're seeking out commercial arrangements and financing, and we're permitting at a localized level. And all these work streams are undergoing varying jurisdictions or are not coordinated. So it's extremely important that developers have clarity on its permitting path and which projects we should be invested in very early from the onset, so that we're not wasting our time or the community's time through the review process, especially considering some of this equipment can take 2.5 years plus to be delivered on site. So by the time you go for the inception and idea and origination of a project to actually having equipment and steel on the ground, you're looking at 5-7+ years to actually do so. And when you think about the aging fossil generation assets that we have today and the contracts that they're essentially financed by expiring, it's crucial that we really kick off this transition now and continue to engage with communities at a local level to ensure that we're working towards this transition and that local siting and permitting is not becoming a barrier to being able to deploy these assets. So with that, I'll conclude my presentation and hand it off to David. Again, I thank you all for the opportunity to speak today, and Key Capture in the industry really does look forward to continuing engagement with you all.
Great. Thank you so much, Phil, for starting. I know a number of you have asked questions. NYSERDA and ESRG are going to speak more to the safety and the parameters around this. So we are going to get to that. Thank you for those of you who are using the Q&A function. Please do that. We will get to the Q's and A's at the end. We are taping this, so we will be making this available to folks afterwards for those of you who want to rewatch, and we'll get you the slides as well when we get this out. So as long as you registered for the event, or if you send us your email, we will make sure that you get this after the fact. Now, with that, David Sandbank, we have Vice President of Distributed Energy Resources for NYSERDA, is going to talk next. David.
Thanks, Julie. Can you hear me okay? I'm hoping y'all could hear me. And Phil, great presentation. That was really hard act to follow, but I'll do my best. Again, my name is David Sandbank. I'm the Vice President of Distributed Energy Resources at NYSERDA, which means I oversee the distributed solar program known as New York Sun, energy storage program, and clean transportation program at NYSERDA. I'm going to start out here, and I think Nick will get into this in much more detail, but I'm going to start out with talking about what sort of standards and regulations and codes there are to deploy energy storage in the state of New York. And I want to differentiate this from, the electric mobility issues and fires that you've seen and heard about and read in the news in New York City. There's a lot of e-bike fire issues in New York City. And it's a big issue that the FDNY is dealing with and the state is dealing with. But what I want to say is that they don't have the standards and regulations that energy storage has in the state of New York. And just to show you these particular points on the slide, talks about all the standards you have to get through just to deploy something in the state of New York. You've got the Underwriter's Laboratory, which is more of a fire safety testing and equipment listing certification that you have to get prior to deploying in New York. Obviously, there's the minimum standards you have to comply by in the New York State Uniform Code. It's minimum. So this code applies to every jurisdiction in New York State other than New York City. New York City has its own code for energy storage that is incredibly strict and runs through FDNY. And FDNY is really one of the more sophisticated local authorities having jurisdiction in the country, and really is leading by example on how to teach others on what to do to deploy safe lithium-ion storage in the state of New York. Then, of course, there's the International Fire Code. And again, it's minimum requirements, and it solely deals with fire prevention and protection systems for the energy storage units. And then there's NFPA and FDNY. So Nick will probably get into this a little further, but I'm just showing you that there are a lot of hoops you have to jump through and areas in which you need to qualify in order to deploy storage in the state of New York. Having said that, even with all those hoops, some things slipped through the cracks. And in July of 2023, we had, within a 40-day period, 3 fire incidents in the state of New York that had to do with energy storage. This is unheard of and was concerning. So Governor Hochul responded to that very swiftly and convened an interagency fire safety working group, which I'm helping to lead. That interagency fire safety working group comprises of DISH's Office of Fire Prevention and Control, NYSERDA, DEC, Department of Public Service, and Department of State. It's a very good, consortium of agencies in the state of New York that are all providing their expertise within the working group. And I think it's really important to state, not only is it the interagency working group not only is it the state agencies that are working together to solve this problem and make New York the safest place to deploy storage, but we also have contractors working with us in the working group. Nick is one of those contractors who's going to follow me. But these are national subject matter experts in fire protection and engineering firms and national labs, and also the New York Power Authority. So this working group is a very strong working group that has incredible skills and knowledge, and we're making a lot of progress, which I'm happy about. What we did was we provided tasks and deliverables that the working group is going to be and is responsible for. The 3 incidents were in East Hampton, Warwick, New York, and Chaumont. And what we decided to really focus on, as far as the incidents themselves, we examined and tested for contaminants, and we reported out a summary of findings. What that really means is we got all the data available for water, soil, and air testing, and we examined the data. We put it in a summary report that was submitted publicly by a press release from the governor herself, and the findings were very good. There was no levels of contamination above what's acceptable for water, soil, and air. So there were no emergency room visits. There were no injuries to first responders or anybody in the public. So we were very pleased once we gathered all that data and looked at all the information available that we did not see any poor results from any of those testing. The other thing that we're doing right now in the working group is reviewing the emergency response actions and data. What that means is we're taking a look at the whole timeline from all 3 incidents to see how the projects responded, how the first responders handled the situation, looking at video footage, and really examining what happened through the 3 incidents and providing a summary document on that that's going to give recommendations on how we could possibly do things differently and how we can improve items and also prevent these things from happening again. And then really importantly, the third aspect of looking at these incidents is getting what we call the root cause analysis. That root cause analysis normally conducted and handled by the manufacturer of the battery itself. And they normally bring in a company that specializes in doing that to figure out, the purpose of doing a root cause analysis is what happened, what went wrong, how can we not do this again, what improvements can we make? So it takes a while to do those root cause analysis. Once we get all 3, we're going to put a summary report together and report out on, what the cause of those fires were and what we could do differently. So that's the first part of the working group task, is looking at the incidents themselves. The second part, which is incredibly important, is we're conducting or have conducted a full review of today's codes and standards and regulations. What does someone like Key Capture, if they want to build a project, what do they have to comply by when they're building a storage project in the state of New York? And so we examined all the codes and standards currently required today. And then we came out with a list of 15 recommendations that we think need to either be changed and or added to what is currently required. We completed that in January and published that, and that is open for comment, or was open for comment until this week. I'm going to speak about this a little bit more on the next slide, so I'm going to stop there. But that was a great milestone that we delivered, and I think will have a great effect in the state of New York. Lastly, NYSERDA, when we provide an incentive for projects, energy storage projects, which is a decent amount of projects in the state of New York, we inspect every single project by doing a field inspection with subject matter experts. And we asked ourselves, how are our inspections doing? Could we have prevented these fires if we inspected differently? So the governor asked us to reassess every single project above 600 megawatt hours, um, and which is basically like some of the larger projects. So it's about 60 or 64 projects in the state of New York that we're going back to revisit and take a look at. And we're going to do it with, and are doing it with, subject matter experts in the field that really understand fire safety and understand codes and everything else. And we're going to come out with a summary report on our findings on the current projects in service. And we're also going to come out with a industry-wide checklist of how to inspect these projects and what is the best way to check these projects for now and in the future. So now I'm going to talk more about the code recommendations here, because I think it's really important for those of you who represent municipalities or are considering a moratorium in your jurisdiction, because this is really important. The recommendations, there's 15 of them that we put into public comment for these larger, as I said earlier, grid scale systems. There are 5, as I said, some are updates, some are additions, and then some are additional considerations. What I'd really like to focus on here is that there's several of these recommendations that, to me, are highly critical. There's 2 of them, in fact. One is to do a peer review of a project when you deliver a plan set to a local government. Not every local authority having jurisdiction has the skill set and knowledge, and it's understandably so, to be able to examine a plan set and make a decision on whether that is a project that is worthy of being placed in your community. Doing a peer review is going to give recommendations and help guide local jurisdictions on if it is a project and what the project needs to do to let the community feel confident that it's going to be a safe project. That is a recommendation to make it mandatory. Having said that, it's still in code, and local authorities having jurisdiction today can enforce it, but a lot are not enforcing it. And so this is one area where you don't need our recommendations to understand how to have one of the most critical recommendations we have become enacted now, because you have the right to ask for a peer review. And that's critical. The second one is an emergency response plan. You also have a right to ask for an emergency response plan. It is not mandatory, but the local authorities having jurisdiction can make that mandatory for their own communities. So it's really important to know that some of these recommendations are in code, but a lot of the local authorities having jurisdiction are not taking advantage of them. And I think that's really important to point out. Lastly, I'd like to talk about, I think Phil touched on this a little bit, this is my last slide, is we have a very talented siting team in the state of New York. And they're housed here, at my organization at NYSERDA. They're very, very responsive and very informative, and they really help local communities understand how to site renewables and energy storage in their communities in the right way. And there are chapters and guidebooks that we have, and some guidebooks that just focus on certain technologies. Some are solar, some are wind, and this is storage. And you could see if there's a municipality that's interested in knowing what's the best way to site storage in your community, a really great place to start is with our siting team at NYSERDA, because we have a battery energy storage model law. It's a very good template for you to work off of on how to make your laws and your local laws and standards that work for your community enable the deployment of safe lithium-ion energy storage in your communities. And so you can see these are just 4 chapters that we offer that are going to be able to really help municipalities understand how to do what's best for their communities while also addressing the dire environmental issues that we're all dealing with and becoming play a role. You play your role in helping New York decarbonize for the better good of everybody. So that's my presentation. I will now hand it off to the next presenter. And thank you very much. And sure, I'll be around to answer questions at the end.
Thank you so very much, David. That was great. And I think a lot of folks, learned a lot because they didn't know about NYSERDA's role and the evaluations that are going on. So we appreciate your time. We have a multitude of questions coming up in the chat. We have one last speaker that I think will be able to answer some of those questions. But if not, we're going to circle back and get to as many as possible. But with no further delay, let's introduce our last speaker, but certainly not the least, Nick Petraic, who is the senior consultant with ESRG, which is the Energy Safety and Response Group. So you have a lot of questions about safety in the chat, and hopefully Nick's going to have a lot of answers. Nick?
Yeah, thank you very much. Good afternoon, everyone. Thank you for joining this Lunch and Learn, and a really big shout out and thank you to David and Phil for those excellent presentations. And segue, I'm the lucky one. I get to talk about a really hot topic item, no pun intended, regarding energy storage and energy storage system safety, and that's related to fire standards, fire codes, fire protection methods, and things like that. So, again, my name is Nick Petrakis, senior consultant with ESRG, Energy Safety Response Group. We're sort of a group of either former or current fire service members, firefighters, engineers like myself, professional engineers, and we take sort of the lessons learned from understanding sort of the history of this and also some of the information that we've gathered from our own full-scale fire testing lab, which we have in Ohio, and some of the lessons learned from our incident command portions of the company. We kind of take that together and we take a holistic approach to energy storage systems and energy storage system safety. I'm going to talk about a couple of things today. The agenda is really a little bit of a 101. We did talk about energy storage 101. I might go a little bit deep into those, those sub chemistries and components of it. I'll talk a little bit about the codes and standards like David had mentioned already, but then I'll jump into our fire protection systems that are mandatory, required if you're installing any system in New York State, New York City, or even throughout the country as a result of those codes and standards that are in the NFPA and IFC documents. I'll talk about some fire extinguishment and some suppression items, and a big one, last but not least, is coordinating with the fire department and emergency response planning and training. So what's an energy storage system? We saw a lot of the outside of them. They're kind of like these enclosed, either look like they're in a shipping container or they're these freestanding. What we're starting to see a lot more often now is what we call a non-enterable or a cabinetized system. So it's outdoor, mounted on grade, and there's no internal access. They're not dedicated use buildings. This is probably the most common approach that we're seeing recently for any sort of energy storage. New technologies, new manufacturers are coming out with this approach. It allows a lot of freedom to put these systems in any configuration that you want and scale it up, either from small residential systems that you would see, like Phil had mentioned, like a Tesla Powerwall, to some of your larger utility size systems that are multi-megawatt or even gigawatt hour type facilities. So lithium ion is just a name for the family of subchemistries, and those all include nickel, manganese, cobalt oxide cells that you typically find in your electric vehicles and your consumer devices like your laptops and your cell phones, but even lithium iron phosphate. And we don't really distinguish LFP, NMC. This is when we were developing fire codes, we didn't want to say one technology is safer than the other. We said prove it. And how do you prove it? I'll get to that in a little bit when we talk about some of the fire testing requirements for these systems. So what are the building blocks? We start off with these little independent building blocks. They're called cells. Some of the more historic type cells, the powerhouses for lithium ion, are these 18650s. They look like a typical AA battery. It's the same cylindrical format. You take a bunch of these cells, you interconnect them together to create what we call the module, that next building block that I have up on the screen there. You take a bunch of modules, you put them together, aggregate them into a rack. You take a bunch of racks, you put them together. Now you have your larger unit with whatever power and current that you're looking to deploy energy capacity. So these are all individual building blocks, but this is important when we start talking about fire testing and also some of these safety standards, because they are built on the individual building block of that safety of that individual cell and module all the way up to the safety of the entire energy storage system. So ESRG, we have a tremendous amount of history. We've worked on these codes and standards since its inception. Before I joined ESRG, I used to work for the New York City Fire Department Sustainability Unit, where we actually I was one of the team members that developed the rules and the codes and standards for outdoor installations of energy storage systems in New York City, and worked on some of the newer indoor requirements as well. And we're talking back 2014, 2015. So although this technology might seem a little new and novel, it has some history to it. And these codes and standards, David mentioned it. There's a lot of stuff on here. It's a lot of alphabet soup. But really, the reason why I put this up there is that there's multiple layers of safety, multiple requirements that are implemented there that are, mandatory if you're looking to install any of these systems. And it goes all the way from the base level, from that module design, from that cell design and that testing to the larger energy storage system, UL 9540 and 9540A, when we talk about full-scale fire testing. And that is a really unique one. Full-scale fire testing is a unique requirement that's really only implemented for energy storage systems. Other generating technologies, you're not required to force them into a failure and see what happens to make sure that you have a safe system. There is a really robust testing requirement that's associated with this technology to make sure that it's safe. If we understand how it fails, we can understand how to design these fire protection systems. Really critical ones like explosion protection to make sure that it does not deflagrate, and also proper spacings and separations to make sure that if there's a fire in one system, it's not going to jump to another system and involve a larger portion of that facility. So I'm going to break it down to some of these layers of protection. Some of them are external to the system. Some of them are internal. These are all very important and mandatory in most aspects of the fire codes. And it starts off with your alarm and detection. Same way that you would have an alarm system within a building. It's connected to a central station. If there ever is a notification of a fire, it can dial out directly to the first responders, to that fire department, and they'll be aware of an issue that's occurring in relation to this system. If it's indoors, you could use smoke detection. For outdoor systems, you can use what we call radiant energy sensing, where it's an external detector. Either way, NFPA 72 and these safety systems are really a critical component of not only the monitoring of the system, but ensuring proper emergency response and notification as well if there is something that's going on in relation to this system. Explosion protection is one as well. It's sort of a family of different ways that you can do it, but we really hold this one near and dear to our hearts to make sure that this is implemented in every single application, because some of the previous events that have happened many years ago in 2019, the APS fire was sort of a big eye-opener in the industry, and it sort of changed the requirements for energy storage moving forward. There was, immediate changes to the codes and standards to make sure that an event like that does not happen again. So explosion protection and making sure that these systems are installed and properly designed is probably one of the most critical safety components for energy storage systems. You could either do it with exhaust ventilation systems, it'll trigger on detection, it'll vent those gases out, or you can do it with panels that will, weak panels that will open up if there ever is an overpressure. Similar to those external, I'll call them external sort of fire protection systems, we have the internal protection systems from the battery. So this system itself, the eyes and ears, the brain of these components, we call the battery management system. You can see some examples here of that human-machine interface that we have. This, as subject matter experts and assistants to the emergency responders as a certificate of fitness holders, this is the information that we can take and we could provide it over to that incident commander, to that chief that's on the scene, to give them the best guidance. We develop emergency response procedures. We're really big on making sure that every site has an emergency response plan and it's trained regularly on a yearly basis. But again, this is one of the components, one of the safety components. It keeps the battery operating within those limits, but it also gives us information about what's going on inside and allows us to give guidance to the first responders to see what's happening within these boxes, because there's not much that you can see from the outside often. Fire suppression systems really are dependent on where it's located. Indoor, outdoor, indoor systems, walk-in units will require this mandatory, assuming that this is in a building as well. Outdoor systems, they're more reliant on making sure that that fire or that failure is contained within that enclosure and it doesn't propagate. So they're not required to be provided with any sort of external or water-based fire suppression systems. It's really dependent on making sure through that fire testing results to show that you can contain that failure either to the initiating rack or within that enclosure, and it doesn't spread to adjacent systems and adjacent exposures. Really big, going back to 9540A testing, making sure that systems are tested. And then we come in as emergency response guidance. And what do you do even for the questions come to us often? We're a smaller, we are a volunteer fire department. We don't have any of these special tools. I think one of the most important special tool that you would need as a fire department, if you have a system in your jurisdiction, is knowing that the system is there and getting proper training through emergency response procedures to understand what the hazard really is and how it can fail. Our emergency response procedures are very defensive. These systems are designed to either contain that failure. If that failure becomes larger, it can sort of safely consume itself. And on the fire department end of it, you can be very defensive. You can limit the amount of water. You can just sort of let it safely consume itself. And when you do that, we don't have to worry tremendous about any sort of water intrusion or water leakage, because water is really not used unless it's just to cool or wet the perimeter within the facility. And water is still the best agent if you have access to water. It's still sort of like a double-edged sword. So we want to make sure that we don't use it aggressively, because it could oftentimes, if it's used too aggressively, extend this duration of failure. If you're more defensive, it could sort of fail as designed in a relatively quicker manner, rather than extending that duration out. So we do a lot of testing on electrical leakage. Like I said, we have our own full-scale fire test lab facility in Ohio. So a lot of these, and we test full-scale systems. We do full enclosures. And a lot of our lessons learned, we incorporate into our emergency response procedures. And we take those emergency response procedures, we go to the site and we train these first responders firsthand. We open up these systems, we have them get an understanding of what it looks like, but we also do a classroom seminar to kind of show them what energy storage is all about and what are the best standard operating procedures if you have one of these in your backyard. And I think it's probably one of the most critical components, especially if you're a fire department and a volunteer, you have a lot of mutual aid. Understanding what's in the neighborhood, a well drafted out emergency response procedure is one of the most critical aspects for safety for any of these facilities. And this is what we do. We sort of develop these, we do the training, and we also do site familiarization on top of consulting as well to make sure that systems are installed safely and in compliance with all of the codes and standards. So that is the end of my presentation. And I appreciate everyone's time today. And hopefully I was able to give everybody an introduction and an understanding of all the different layers of safety that these systems are required to have.
Thank you so much, Nick. That was great. All right, we're going to do rapid fire. Is everyone ready? And we're going to ask the questions, and we're going to ask our three panelists to please keep your answers short. There's a lot of really great questions. I see we have some elected officials asking questions as well. So I'll start. Okay, first one. This one says, are you aware of any forthcoming, and it's by anonymous, so I don't know who that is. Are you aware of any forthcoming revision periods to NYSERDA's model local law as a result of the New York State Working Group recommendations?
So thanks. Yeah, I'll try to handle this quickly. Not so sure it'll be a revision in our model law, but what we will do is incorporate and highlight the really important critical recommendations within NYSERDA's program and make it a requirement that any project coming in is going to probably have to do a mandatory peer review. We're going to implement a much more stringent quality assurance, inspection, field inspection, and we're also most likely going to implement the emergency response plans and make that something that is mandatory up until the 2025 code adopts our recommendations.
I'm going to answer something quickly. One is the question of if the slides will be made available, and the answer is yes, we will make the slides available. And also earlier, someone had asked for a link to the guidebook that David had referenced in his presentation. That has been provided. It's in the Q&A from Justin Alston Payne. So that has been made available. One of the questions is, are we seeking support or information from California and federal government as you're looking at the standards?
I could jump in on that one real quick. Also, California Fire Code right now, they're in the 2022 edition of the California Fire Code based on the 2021 International Fire Code. The New York State edition of the Uniform Fire Prevention Code was actually developed in 2020 when the 2021 International Fire Code wasn't released yet. So in New York State, we actually have probably one of the more recent and robust editions of the International Fire Code adoption. California is doing a lot of really important things, especially on the emergency response procedures and making sure that those are mandatory and those are trained with the local fire department. I think, as David alluded, those are going to be in the code recommendations report.
Okay. I just want to make sure we've answered the councilman's question. We have a councilman from Islip on there. Hi, councilman. It says the need for battery storage is evident. But his concern as a councilman in the town of Islip is the handling and managing of the fires at any locations. Are any new methods in safety combating these fire facilities available?
Yeah, there's no sort of magic bullet solution to this. That's why we take a sort of holistic approach to safety. In part, it's not only the safety of the technology itself and making sure it has all those proper listings and standards and those full-scale fire testing to make sure that everything is sort of taken control of on the fire safety end within the enclosure. Now, when we go outside of the enclosure, that's where our emergency response procedures and proper training come into effect as well. Like David had mentioned, proper maintenance of the site and things like that. We take all of these safeties, we take them together on different levels, and we try to ensure that any sort of failure is minimized to the maximum possible. We kind of minimize those by taking this holistic approach. So, like I said, there's no sort of one size fits all solution. You really have to holistically go all the way down from the technology and all the way up from the site itself and the training.
And just to add to that, Nick, I mean, it was within our recommendations about training fire departments. It's really important to understand that a lot of these fire departments are volunteer. And not only should the training happen at the beginning when you're energizing the system, but it has to be on an annual basis for people who might have missed the first year. And I do understand Islip is voting or has voted on a moratorium. I'd ask you to please reach out to me or us if you need any guidance there. Because we have a lot to offer if you feel free to reach out to us.
All right, we got a few questions asking about sort of the lifetime of the batteries and how frequently they might need to be changed. And then I'm going to add on to it only because we're in rapid fire here. Are there other technologies being pursued? Someone suggested a different type of lithium could potentially be used. So it's kind of a compilation of like at least 3 people's questions here.
Well, Phil, could you talk to how long the batteries last?
Sure. Yeah. So it really depends on the project and design and the use case. If you're cycling the battery very, very often, it's going to degrade faster than if you're using it for a capacity purpose and then essentially there as a backup. But generally speaking, we're designing our systems to last and having a project life of approximately 20 years. So essentially what that means is that we're going to overbuild the system on day one to account for some of that degradation and then periodically augment the system over time to ensure that we're essentially rebalancing the load on the batteries so that their state of health is degrading at an equilibrium across the entire project. If you look at the warranties and the spec sheets provided within these OEMs, typically we have to comply with a certain battery state of health, which essentially means that we need to stay above typically around 70% of the battery state of health. And that's to ensure that, cell defects and some of the thermal promulgation issues that have been of concern are not becoming an issue. So we're essentially augmenting
this
over
is the
time.
rapid fire portion of the.
Okay. Sounds good. Approximately 20 years, depends on the design.
And what about any other types of batteries or technology being considered?
I saw the question about lithium iron phosphate. Typically, that seems to be where the industry is trending. Some of the first projects that were brought online at the utility scale dating back a decade, 5 years ago. There's the NMC, nickel, manganese, cobalt, was more prevalent. But today, it seems most of the bulk scale systems are trending towards lithium iron phosphate. And that's typically what Key Capture is building.
Okay. Saul is asking, what about multiple small-scale installations on existing substation locations? And similarly, making it economical to draw from residential installations?
Yeah, I think this goes back to my point about some of the wholesale market changes that are occurring, which are largely being driven by FERC Order 2022, which essentially requires that ISOs allow for bidirectional flow of energy. But yes, like in today's market, there is an opportunity for bidirectional flow of energy from residential generation and other behind the meter resources. And to his point about small scale, battery storage at substations. I think we need a host of different scales of battery storage, both on the transmission system and distributed throughout our grid to ensure a reliable and clean energy transition. So at all scales matter.
So I think on that one, another question that we've seen here is folks are wondering if they're looking at putting storage at their own homes, which is obviously not the big ones that we've been primarily talking about. What safety features should they be looking at? And I will mention, as an aside, we do have a guide on the Inflation Reduction Act on our website, the NYLCV website, that talks about rebates and tax credits that are available to help people purchase storage systems and solar.
Yeah. So residential energy storage systems, and I talked about some of the larger systems and those protections. The good thing is that the way the codes and standards are built, it's scalable. Even small residential systems, there's a dedicated chapter in the international codes and in the 855 standard, listings, full scale fire testing, some prescriptive requirements, same sort of criteria for safety. So even residential systems have to go through some of those really scrutinization for those standards for safety.
Okay. Dennis is asking, why did it take several days or weeks to respond to testing the air and water of that one fire?
Nick, do you want to take this, or do you want?
I do know that our findings are going to be made public eventually, right, David? So not sure how much I could say on it if you want to elaborate.
Yeah, I think we provided our findings that are public now. We're not the ones who collect the data. We're the ones who collect the data. We're not the ones who go out and get it. So that's up to local fire departments and DEC and county and other organizations that do that. And we just collected all that data and looked at it. There are probably very good reasons why, it was tested when it was tested. There's very different circumstances from one project to the other. For instance, with firefighters used a lot more water in one site than another site. That site happened to have well water around it. And so that was a concern. So they tested the water quickly, whereas another site didn't use as much water and didn't have well water near it. So it just really has to do with what the decision making was done at the time from those professionals in those regions.
But I think that speaks to a question we get a lot at our office about the training of firefighters when they go out and have to respond if there is an incident. So I know that's something that NYSERDA is also working on. The councilman again has a question. He just wants to know, is it safer to store these containers in concrete chambers? Which I think you kind of touched on, but.
Yeah, and we talk about, regardless of what it's stored in, you still have that potential, to if there's an off-gassing, you just have an enclosed environment with some of the off-gassing from this battery. So it still holds, whether you're in a non-combustible steel enclosure, whether you're in a concrete enclosure, you're still going to want to have those same fire protection systems. And I think for the most part, safety requirements will span across any sort of enclosure. The way that the industry is going now with these outdoor containerized systems is very favorable for safety because they're not occupied. It's a very, remote sort of a facility where we have fencing that's going to be outside of any of the hazardous areas from those nearest enclosures. It works very well, and we've been seeing the entire industry shift there because there's a tremendous amount of safety that sort of follows that sort of equipment layout.
All right, let me just get one more question in by Anonymous. Can the BESS sites be set up with existing transmission infrastructure, or does the transmission equipment need to be upgraded at the same time?
Yeah, I can address this question. So, the answer is there's always going to be some degree of upgrades, and depending on the project design and location, that varies. Some of these projects are directly sited next to existing substations, in which case there might be an open bay to connect directly into an existing breaker, or you might need to expand the aluminum bus and build a new breaker, but the footprint is relatively limited. Because of some of the need to be affixed directly to transmission infrastructure, projects in certain towns, there's not available land available directly next to a substation. So in certain instances, we do build along transmission lines instead. In that instance, we are building a new substation basically for the utility to own, and then building a project directly next to that utility. But we do think in certain instances that's actually favorable for siting purposes because it allows you to site projects where you otherwise would not be able to within the town and kind of buffer yourself from sensitive receptors.
So thank you so much to everyone for all your great questions. Thank you so much to our panel, to Phil, to David, and to Nick. This was really informative. As we mentioned earlier, we will provide the slides and a link to the video after this. There was a question about who to direct follow-up questions to. You can reply when we send the email out with that information, and we will do our best to gather additional information. I don't know that this will be the last time we have a video to talk about battery storage. We know it's something that's coming. We know that it's something that needs to be done, but it needs to be done safely. And we want to make sure that it's done in a way that's helpful to everybody and communities feel comfortable with it. So on behalf of the League of Conservation Voters Education Fund, thank you for participating. Adrian?
Yeah, and again, just thank you, everyone. And we had this forum because we got so many questions from members of the public and from council members and town people who are grappling with this new technology, figuring out how to site it, how to do it safely, but how to do it. And I think it's always great to have more information, and the more information, the better decisions we can all make. So that was the goal today. I'm sorry we didn't get to everyone's questions. There were probably 100 questions in the chat, so please don't take it personally. We will have more of these in the future. Thank you again.